We have our velocity set. We might want to color some of these. This is going to be a nice, beautiful green because that's great. You can color some of these other boxes if you'd like. But now what we need to do is we need to move over and we need to look at how to, I'm going to double click to get out of that, how to adjust our vertical, right, our rotation in the Y. So I'm going to go to my main camera and I'm going to click Add Component. I'm going to go to Bolt. I'm going to make a flow machine and I'm going to create a new macro just to house this. And I'm going to call this one camera mouse look toot. And I'll save this in my scripts, wherever that may be. There we go. So the first thing I'm going to do is, well, I'm going to delete the start event. I don't need that, so I'm going to get rid of it. All I really need is update right now. And the first things we're going to do is we need to basically get our mouse Y input. So we're going to go ahead and have our flow go to an input dot get axis. And we want the axis name, and we want this to be capital MOUSE space Y. And then we're going to want to put this value into a variable. And we will call this variable mouse Y. So I'm going to go to my graph variables. I'm going to title it mouse Y plus, make it a float. And I'm going to be setting this, so I want to select my graph, hold down Option or Alt, click and drag, and hopefully the set variable will pop up. Connect this over and connect this here. Okay, so we're getting our first variable. Now, the other things that we need to do is we need to essentially add this value onto whatever our current rotation is, and then save that current rotation and check it to see if it's within the range that we want. And if not, we're going to clamp it. And then we will set the final rotation. That seems simple, but it's going to take several steps. So first, we're going to need to get our current rotation in degrees. So we're going to add a unit, and it's going to be transform dot local rotation, and we want to get that. And then we are going to need to create this is a quaternion. We're going to need to turn this into Euler angles because we're only going to be dealing with the X rotation, right? The red line that's up here in the window. There we go. And so I'm going to say quaternion. And if it's close, I don't see it there, but I'm just going to say dot EU for Euler, and we're going to say Euler angles get. And then the next step is we only want the X, so we're going to come out of here, we're going to click, and we're just going to say set, oops, not set, we're going to say get. And we're going to get the vector 3x. Okay. So now with these three, we've got the value that we want to be modifying. And now we need to go ahead and begin to modify that value. But before we do that, we want to, there's one last thing we need to do. We need to take this mouse Y value, and we need to do those steps that we've done on every other motion example we've done, where we set a speed and we set a, and we use time delta time, right? And we're going to do two multiplication things to do that. So I'm actually going to come down and I'm going to grab these. I'm going to pull them down a little bit because I want all the stuff based around mouse Y to be lumped together. So down here, I'm just going to click on mouse Y, I'm going to drag it down. I'm going to create a variable, and this could either be an object variable. In the end, it'd probably be better to have a scene variable because I'm going to want to change it in a couple places, but that's fine. So notice that because I've already made these variables, I've already got it here. So what I'd like you to do is create this R speed. Go ahead and set it to 40. It's a much better speed, I have found. But this just means rotation speed, and it's the speed that we're going to want. Essentially, it'll create a value that will give us the number of degrees that we want to rotate per frame. So I'm going to go ahead and pull this down. And what I want to do is maybe give myself a little bit more space and open this up. All right, so I've got my mouse Y, I've got my speed, and I just need to multiply these. So I'm just going to type in mult. And I can use the generic in this case. And then I'm going to want to also bring in time delta time. But first, I'm going to go ahead and copy this multiply and paste it. Take this top value here. And then from this one, I'm going to go ahead and click. And I'm going to say time.de should give me time delta time. Oops, grabbed the wrong object. There we go. OK, so then all of this, then I want to add to this variable down here, right? To whatever this x value was, I want to add these additional degrees to this. So I'm going to come down here, and actually what I may do is I may make this my top value, but I'm going to say add, and we will say in math generic, that's fine. I'm going to add my change in degrees to that. And then what I need now is I need to create a variable to store this. It's just going to make my life significantly easier as I go forward if I have a variable for this. Now, this can be a graph variable. It's not something that we need to modify or have access to at the object level. So I'm going to go ahead and just call this, maybe I'll just call it rotation. I mean, we could call it X rotation or whatever, but I'm going to call it just rotation. And I am going to make it a float. And we're going to be setting this, so I am going to select my graph, and then I'm going to hold down Option, click and drag, and pull this out. And I'm going to feed this value in here. And now I've got all of this set up, but I need to connect it. So I'm going to go ahead and just run my flow from here to here, right? So the first thing that's going to happen is, right, mouse Y is going to get set up. And then once that gets set up, this flow is going to come down here, which is going to essentially trigger all of these things to happen in order to set this value, right? So now we have our current rotation. And so what do we need to do now? Well, ideally, we take this current rotation, and let's just see what happens when we directly update the local rotation with this. So there's a couple ways we can do this. I'm going to go ahead and click on, So first, this is a float value. So we're going to need to be able to turn this into a vector 3. So I'm going to say add unit. I'm just going to say vector 3 new and XYZ. I'm going to pull my flow over here, and I'm going to pull this into the X, right? We're doing the red rotation, which is, up and down as far as our camera is concerned. So now that I've got this new vector 3, I'm going to need to use it to set my angle. So I'm going to go ahead and click add unit. I'm going to say transform dot. Now there's several options here, and it gets really confusing, but what I want is probably the transform Euler angle set. That's the most efficient way to get there with the fewest number of units. And if there's an issue with using this, hopefully we will not find it right now. Okay, so this would basically grab our mouse, add it to the rotation, set this new vector 3, and then reset our rotation here, right? So let's go ahead and see if this works. So I'm going to get out of full screen, and I'm going to run this and see if I get movement along the x-axis. Okay, right, or around the x-axis, right? So I'm getting, okay, so we've got rotation working, and because of the way that we're doing this, it maxes out at 90 degrees, or at basically, we have 180 degrees of motion, which is exactly what, not exactly what we want, but right, we don't need to be able to flip our head around behind our bodies in this case. And so using the code that we're using will work. Now the issue is you can see that as I hit this boundary, I get a lot of jitter, and the same goes for up in the sky. If I can, I don't know if you can see it, but if I can find the sun, there we go. Right, you can see that as I'm continuing to push, it jitters all over the place. So what I need to do is, one, I don't want to be able to look quite as far as I'm looking. And I want to be able to basically have a smooth point where when I hit that boundary, it stops and it doesn't hop and skip and jump all over the place. So let's go ahead and do that. But first you may notice that the 2 units at the end of my graph, and I'm going to hit escape here and stop this, are different than the units I was using before. I was doing some testing to see if there was any real difference, and I didn't notice any. But I just want to say that doing this and doing this are more or less identical in our use case, in terms of setting the angles, right? We can either create a new vector 3 and we can feed this into here, and then feed this out into here, and we're transforming the local Euler angles. This is a slightly different, right? We're going to transform our local rotation, which is the same thing. However, the local rotation is stored as a quaternion, which actually has 4 values. It's a 4-dimensional vector. So it has x, y, z, and then another value, w. And, I don't really understand quaternions all that much, but basically the w allows, kind of keeps track on how to create the smoothest rotation between axes. I don't know how else to describe it than that. And so if you were doing something where it's a space shooter, or you're able to turn and fly, it's some sort of flight sim or something where you have a lot of control, this is probably what you would want to use. But in our case, we could use either of these because, right, we're not doing any crazy, rotational movement in multiple axes that we need to keep track of in terms of like a path between those rotations. So we're going to go ahead and I'm going to leave this as it is, but you could use these units as well. So what we need to do is we need to clamp our range of motion in the x-axis, right? And so there's a function called clamp or a unit called clamp that would work really well. However, if I was to go ahead and add this, just type in clamp. There are 2 options. One's a floating point, one's an integer. And then there's also this clamp 0, 1, which actually just clamps a value between 0 and 1, which we're not going to use. But there's this math clamp. This is the floating point one. This is the integer one. Just make sure you click on the first one. And what this allows you to do is it allows you to give some value, like say the degrees coming out of here. And then you set a range on those degrees. And if the value that it's given is either lower than minimum or higher than the maximum, then it's going to either give you maximum if it's greater than the maximum, or it'll give you the minimum value if it's lower than the minimum. And so this will stop jitter, and it will allow us to control the total range. Now, there's an issue here, and that issue is that the rotation, what would be great is if we could say, oh, well, I want it to be max to be like, say, positive 60 degrees and minimum to be negative 60 degrees, right? That'd be great to have that range. And if I was to look here in my rotation field and drag this around, you'll see that as I, move my X up and down, you'll see it does go negative. And then it goes positive as I go down, right? So positive 90 is all the way down, and negative 90 would be vertical. Now, that's all fine and good. I'm going to set this back to 0. However, this is only for humans to read. The actual way that this works, and I feel like I've talked about this before, so maybe it's a repeat, but whatever. The actual way that this works is that the degrees are right from 0 to 359 degrees, right? And then 0 and 360 are the same. So So what actually happens is when I go negative, I'm actually, in terms of the numbers that are going to be generated through all of my code, instead of a negative degree, it's actually going to be giving me 359 degrees, 358, 357, 356. And that's what's called rollover. When you go around a range of values from, say, 0 all the way to 359, and then you hop back to 0 and go to 359 again. That's called rollover. Or vice versa, if you're going down from 359 to 0, and then you pop back over the other direction. And that causes a huge problem, right? Because if we tried to use clamp, what's going to happen is we are going to have our minimum value, if we set that to negative, say, 60, and our maximum value to 60, we'd be able to do the 0 to 60 fine. That side would work. However, let's go ahead and plug this in and just see what happens. So let's say we have negative 60 here, and we have 90, or not 90, we have 60 here. So let's go ahead and just feed this in, right? So I'm going to put my value in. You know, it would be a great, beautiful world if we could just use this as it stands and it would work. But that's not the case. We actually have to do a fair amount of work to get this to function the way that we want it to. And so we're going to create some super units to do that and make our life easier. So if I go ahead and play this now, and I move this vertically, sorry, if I move this down, I hit this hard boundary. Notice there's no jitter, right? That's just me moving my mouse side to side, but there's no jitter, right? I hit the bottom, fantastic, that works really well. I bring this back up towards 0, and as soon as I get past 0, it pops back down to 60. And the reason for that is that this, right, it's getting to 0, and then the next degree is 359, and 359 is bigger than the maximum value. So it's kicking us back down to 60 degrees because it's larger than the maximum, and that's not what we want to have happen. So let's go ahead and stop this. And we are going to we're going to leave the unit in there for now, but we are going to create a couple of super units that are going to fix all of this. So the first thing we're going to need to do is we're going to take this raw number of degrees and we want to wrap it up so we can actually get that range of values from, say, negative degrees to positive degrees. And then once we've done that, we'll do that. We'll feed it through this clamp. We'll get whatever output, and then we'll unwrap it so that, you know, negative 60 degrees, if that's what we're using, would end up being 300 degrees of rotation, and the positive stuff would stay the same, right? So then this will be fed correct degrees, so it will do what we expect it to do. So let's go ahead and get started making those super units. And the reason we're making them as super units is because it's going to make our life a lot easier, just because there's a lot, this graph would look hideous if we were to not have these as super units. So I'm going to right click off in space. I'm going to type in super, and I'm going to grab a super unit, and I'm going to title this one, before I do anything else, I'm going to title this wrap angle. And what this is doing is it's essentially wrapping around the 0 point, our angle, from what we're going to be doing normally. I'm going to leave it as an embed. I'm going to click Edit Graph. So let's start with our input and output nodes, or units, or whatever they call them first. So first, control inputs, we need a flow in. And then we're going to need our rotation, right? The degrees that we are setting. So I'm going to type in rotation. And the type that I want this to be is going to be a float. And then on the output side, right, we're going to need to have our flow out. And then we are going to need rotation, and I'm going to call this rotation out. Just because I think you can't have the same value on in and out, so I just don't want to make that mistake. So I'm going to say float. Okay, so I've got my two nodes here. I'm going to have my rotation value coming in from my other graph, and then I'm going to do some stuff, and I'm going to have my rotation going out. one of the first things I'm going to want to do is I need to create a couple temp variables in here. So I want a graph variable, and I'm just going to call it, I'm going to call one just angle, and I'm going to make that a float. And I'm going to want to, the first thing I want to do when I get into the graph is I just want to set that to whatever angle has come in through rotation. So I'm going to select my flow graph. I'm going to hold down Option, click and drag to get my set variable. Okay, so I'm going to need to set my variable. So I've pulled this down, but I'm not going to be connecting this yet. Actually, I may connect the flow, but I'm not going to be connecting this directly here, because what we need to do is we need to modify the angle somewhat. And so what we're going to do is we're going to have this, we're going to put this modulo unit in here. So I'm going to come out of my rotation. I'm going to click. I'm going to type MOD. That should get me there. And I'm going to say in math scalar. Now, what the heck is modulo? It looks like a percentage. And that's sort of right. Modulo is a special function that if you think back to elementary school math, where you were doing division and you had a remainder, right? So you, before any of us learned anything about decimal places and anything like that, right? You would say, if you had, say, 13 and you wanted to divide that by 2, you would get 6 with a remainder of 1, right? So modulo does that same function. If I had the value 13 come in here and I set this b value to 2, right, it would be, the modulo would just be the remainder, right? So it would just be 1, right? Or if I had, let's say it was 10 and it was 13 modulo 10, that means that it would say, well, I can take 10 out of it and I have a remainder of 3, so it's going to send out 3. So in this case, we know that a circle has 360 degrees. Now, this is something that future-proofs this object, right? We are only going to be able to, right, we're only rotating in a total of 360 degrees. So no matter what value we put in here, we're going to get the same angle out. However, if we were to be doing, like, maybe something's rotating 720 degrees, or because it's 3 full rotations, or there's like a higher number of degrees that are being used, this modulo is going to allow us to just grab, essentially make it back into a single circle, right? So instead of 720 degrees, right, that would actually, you know, result in 0 coming out of here, because it'd be 0 or 360. This also means that if we do have the value of 360, it's going to be converted to 0. But everything else is going to come out. If it's 359, right, we're going to get 59. So, so let's go ahead and we do that. And that just is going to help if we use this for other cases in the future. So we've got our modulo, we're setting our angle, and now we need to go on to the next step. Now, I've actually done this before and I'm trying not to make a mistake, so I'm going back and forth between. Okay, so you can see here in the graph that I've already created. We can kind of talk through this and then we'll go ahead and create it on our own as well. So I've set the angle here, right? I've got my modulo. And then what I need to do is I need to check, and you know, one of the things about visual programming is things are a little bit backwards in terms of how they read, right? This is the thing that I want to do. I want to be checking to see if the angle is greater than 180 or not. And if that angle is greater than 180, then I'm going to do something over here. And if it's not, I'm going to actually just send the angle right back out, right? So if we look at this and we think about our angles coming in, so let's say we have 60-degree angle coming in. We're at the bottom of our range, right? And so we come in here, we say, you know, 60 modulo 360 is going to give us 60 out. It's going to come up here and we're going to go to this branch, and then we have to kind of backtrack and we say, okay, well, is 60 greater than 180, which is the number of degrees that we're looking at using? And the answer is no. So then we follow the false and we say, okay, well, that false value is going to come out. Temp angle, which is 60, is going to be sent out the output, and we're good to go, right? That shouldn't be changed. So now let's look at something that's, right, greater than 0. Let's say we let's say our angle is 300, which would be equivalent to negative 60 degrees, right? So it'd be the other end of our spectrum. So we come through here, we say, okay, we're going to say 300 degrees. It'll stay 300 degrees because this is bigger than a circle, a single circle. And we're going to come in here and we're going to flow up here and we're going to say, is 360 or is 300 greater than 180? The answer is yes, that's true. So then what are we going to do? So this is where the wrapping happens. So we're going to, if that's true, we're going to take our angle value, so 300, we are going to subtract that 300 degrees from 360, right? Or sorry, we're going to subtract 360 degrees from our angle, right? Which is going to give us that negative angle. So this, in this case, if this is 300, it's A minus B. So 300 minus 360 is negative 60. And then we're going to send out that negative 60, right? So all of this code in here basically is going to allow us to check to see if our angle is bigger than a certain number of degrees, right? Specifically 180. And if it is, then we are going to change it and make it a negative value so that we can use our clamp successfully. Okay, so let's go ahead and build this in our graph real quick. You might have already done that. Like, I'm sure you could pause the video and just fill these in, but I wanted to go through the logic all at once. So let's go ahead and build this on our camera. So I need the greater than branch and everything else. Edit my graph. Okay, so we need a greater than. So greater than, and we say 180 degrees, right? And what we want to test is our angle variable. And for whatever reason, even though it has this output here, it gets real tweaky if you go from here straight to here. So we're just going to grab this again so we get a get angle or a get variable, drop this into the A, and it just makes it a little cleaner. Okay, so we've done that. So now what do we need to do? So now we need to check, right? We're doing this check, and now we need to act on that check that we've done. So we're going to say add unit and control and branch. And we're going to take our true or false value coming out of here, put it into branch. We're going to connect our flow to our branch. And then, so if this is false, what we want to do is we just want to go straight to our flow, and we just take whatever angle we've got. I'm going to go ahead and copy and paste this. And we want this angle to go out. Now, if this is, on the other hand, if this is true, and I am going to actually pull this stuff a little bit further over because I know I need a bit more space over here. However, if this is true, I need to make that change. So I'm going to go ahead and copy and paste this get angle again, and I'm going to do it up top and give myself a little bit more room up here. Maybe I'll just double click to get full screen. So I need to get my angle, and then what I'm going to need to do is I need to subtract. So I need to say subtract, and I'm going to say math scalar so I can just hard code that value in, because right, 360 is circle is always going to be 360 degrees. We're not going to need to change that. And we want the 360 to be in the B value because we want to create a negative number. This angle should always be smaller than or maybe equivalent to 360. But because 360 and 0 are technically the same value, we're probably only going to get 359 here. So, we'll get -1, and otherwise it's going to be 0 degrees, which will mean that it's going to flow through the normal branch. Okay, so I'm going to subtract that. And then what I need to do is I need to set my angle variable to whatever that is. So I'm going to say copy and paste this set angle. I'm going to put this in here. I'm going to take my true branch, flow it up through here. And then once I've done all of these steps, then what I need to do is I just need to come down to this output flow. And right, because I'm setting it here, then I'm getting it here. I don't need to do any further connections there. I can basically, no matter what, I want this angle to go out. But if it's true, I do something to it so that when it goes out, it's different. And if it's false, I just send it straight out. Okay, so this is the wrap. Pretty exciting. So let's go ahead and go back to our main camera script. And so I'm just gonna scoot some units over a little bit, and I'm leaving them small just because it's easier to see the whole graph. So I'm gonna come down here, and I'm going to delete my flow, delete my connection here, and I'm gonna move this in, flow out, and put this in the value. Okay, so I've got my wrap angle set, fantastic. And now this clamp should work. However, I'm going to get garbage values over here. Let's see what happens when we do this. My values should be coming out accurately, but I think right, so I've got 25 degrees, 14. Now I'm getting negative values all the way up to negative 60. Okay, so I've made this wrap angle unit, and you can see that I don't even need to unwrap it. The Quaternion sees it correctly. Now, what I want to do is I'm going to go ahead and check. I'm going to connect these other units and see if I get a similar result or if it freaks out on me. And if it freaks out on me, then I'm going to suggest we use the Quaternion, just because it's going to simplify the amount of work we do and the number of steps that need to be taken in order to get this to be usable data. So I'm just going to come down here with these two things and see if I get something correct or if it freaks out on me on this side. Because it may be that the Quaternion does a little bit of extra math to make things right. No, this works too. All right, so either one of these works, right? As long as we get our as long as we wrap the angle up and make it negative, then we are good to go with clamp. Awesome. Excellent. So either one of these will work. Technically, this is a little bit less expensive in terms of optimization. So just using vector 3s rather than using Quaternions. So this might be the more efficient route to go. Depending on what your end purpose is and end platform, it might be safer to use this unless it ends up causing problems later on down the line. And if you get to that point, it may be beyond my expertise. Okay, so that's the end of this tutorial. We now have mouse look, and we can move around the scene. Now, one thing I may have forgotten to mention is what happens. Oh, sorry, I'm going to actually, I didn't mean to stop it. I meant to click in the window. What happens when we hit some terrain? So I'm going to go ahead and run around, and you can see that, you know, my left and right rotation's a little slow. I might want to increase that. But if I come up here on these mountaintops, right, you'll notice that I'm not flipping around anywhere. And I can't remember if I said this earlier in the tutorial, so I want to show you how to fix this if your character is flying in all different directions. So, right, so if I don't have my Y rotation frozen on my rigid body on my player and I'm on uneven terrain, I just start spinning randomly, right? And that's because, right, with these different angles and things, my collider is sliding a little bit and rotating around this point. And so if you're trying to climb on rough terrain and your character's just spinning in circles, like, you know, chaotically, just go ahead and obviously stop the game so you do this, but check mark that freeze rotation in Y under your constraints. And as soon as you do that, your character will only rotate under your command to do so. Okay, but we've got jump, which that's a really huge jump, but you know, it's fine. Maybe we're on the moon or something. So we've got jump set, right? We can run across the terrain wherever we look is the direction we're headed. And we now have a fully functional player controller. All right. Now, crouching and walking slow and things like that, those are all steps that you could, you know, that you could take from here and go forward with. Okay, that's all I've got.